Today we're going to talk about solving quadratic equations. There are 4 methods for solving quadratics. You can solve by factoring, by taking square roots, by completing the square, and by the quadratic formula. Today we're going to focus on those first 2, solving by factoring and by solving by taking square roots. When you are solving by factoring, the right side of your equation must equal 0. In example 1, it does. And so when that happens, we can jump straight to factoring. So we're going to be looking at factoring the left side of the equation. Remember that your first step with factoring is to always look for a greatest common factor. In this case, we do not have one. When we don't have a greatest common factor, we can go straight to the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. 2 times negative 30 is negative 60. So I am looking for factors of negative 60 that add to my middle term of negative 7. So if you're not sure, you could think about your list of your factors of 60. So that's 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. And it looks like 5 and 12 are going to work. If 12 is negative and 5 is positive, then I'll get negative 60. And negative 12 plus 5 is negative 7. So those are going to be the numbers that go in the empty spaces of my area model. The greatest common factor of my top row is 2x. The greatest common factor of the bottom row is 5. The greatest common factor of the left side is x. And the greatest common factor of the right side is negative 6. Remember that you can check your work. 2x times x is 2x squared. 2x times negative 6 is negative 12x. 5 times x is 5x. And 5 times negative 6 is negative 30. So right now my factors are 2x plus 5 times x minus 6. And then don't forget, now this is an equation. So this equals 0. From here, we can use the principle of zero products. And if you remember back to Algebra 1, all that means is that if you have 2 numbers being multiplied together and it equals 0, then one of those 2 numbers must be 0. So either this factor equals 0 or this factor is equal 0, because this factor times this factor is 0. So we can just set each of those factors to 0. From here, we can solve each equation. To undo addition, we'll do subtraction. And I'll have 2x equals negative 5. To undo multiplication, I'll do division, and I'll get x is equal to negative 5/2. Don't make this more work for yourself. You don't need to change that into a mixed number or a decimal. Negative 5/2 is perfectly fine. For our second equation, to undo subtraction, I'll do addition, and I'll get x equals 6. Both of these are my solutions. Remember, if you think back to Algebra 1, these represent the x-intercepts. So remember, when you have a quadratic, remember you have things that are parabolas, so those are like things that look like u's or n's. When we're solving these, we're finding the x-intercepts. So this would represent one of the x-intercepts, and this would represent the other x-intercept. Let's look at example 2. On example 2, the first thing you need to check is you need to make sure that the problem equals 0. This one does not. So I need to get it to equal 0 first. And so if this 6 was to move over to the other side, then it would equal 0. So that 6 is positive, so to move it to the other side, I'll have to subtract it. So I'm going to have 2n squared minus 5n minus 7 equals 0. Now that this equals 0, now I can go ahead and begin factoring this one. So again, we're factoring this left side of the equation. Your first step with factoring is to always look for a greatest common factor, and I do not have one. So I can go straight to the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. 2 times negative 7 is negative 14. So we are looking for factors of negative 14 that add to negative 5. And those two numbers are negative 7 and positive 2. Negative 7 times 2 is negative 14, and negative 7 plus 2 is negative 5. These are the numbers that go in the empty spaces of the area model. The greatest common factor of my top row is n. The greatest common factor of my bottom row is 1. The greatest common factor of the left column is 2n. And the greatest common factor of the right column is negative 7. N times 2n is 2n squared. N times negative 7 is negative 7n. 1 times 2n is 2n, and 1 times negative 7 is negative 7. So my factors are n plus 1 and 2n minus 7. And don't forget to bring down your equals 0. So from here, I can use the principle of zero products. This factor times this factor equals 0. So I can say either n plus 1 equals 0 or 2n minus 7 equals 0. To solve this first equation, I'll subtract 1 on both sides and get n equals negative 1. For my second equation, I'm going to add 7 to both sides, and I'll have 2n equals 7. To undo multiplication, I'll do division, and I'll get n equals 7 halves. So my solutions are n equals negative 1 and n equals 7 halves. Go ahead and pause the video and try to solve example 3. So the first thing that you want to do on example 3 is you want to make the right side of the equation equal 0. And so I'm going to add 3 to both sides. So I'll have 8x squared plus 16x plus 6 is equal 0. Now we want to factor. Our first step with factoring is to always look for greatest common factor. And in this case, my greatest common factor is 2. So I need to factor that out. So I'll have 4x squared plus 8x plus 3 equals 0. Now I want to factor completely, meaning I want to factor what's left inside the parentheses. To do that, I'm going to use the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. 4 times 3 is 12. So I am looking for factors of 12 that add to 8. Well, that's going to be the numbers 2 and 6, because 2 times 6 is 12 and 2 plus 6 is 8. Those are going to be the numbers that go in the empty spaces of the area model. The greatest common factor of my top row is 2x. The greatest common factor of my bottom row is 3. The greatest common factor of the left side is 2x, and the greatest common factor of the right side is 1. 2x times 2x is 4x squared. 2x times 1 is 2x. 3 times 2x is 6x, and 3 times 1 is 3. So remember that we have 3 factors. Our first factor is 2 from our greatest common factor. And then we have 2x plus 3. And then we have 2x plus 1 equals 0. And then we're going to use the principle of zero products. Either 2 equals 0, 2x plus 3 equals 0, or 2x plus 1 equals 0. So just take each of those factors and set them equal to 0. Let's look at this first equation. 2 equals 0. Is this a true statement? There's no variable here, so there's nothing to solve. And so I'm trying to figure out, does 2 equal 0? It does not. So that goes away. It's a false statement. For the second equation, I have a variable, so I have something to solve. To undo addition, I'll do subtraction, and I'll have 2x equals negative 3. To undo multiplication, I'll do division, and I'll get x equals negative 3/2. This equation, to undo addition, I'll do subtraction, and I'll get negative 1. So I'll have 2x equals negative 1. To undo multiplication, I'll do division, and I'll get x equals negative 1/2. So my answers are x equals negative 3/2 and x equals negative 1/2. So remember, if I were to graph this equation here, these would be my x-intercepts. Let's try example 4. The right side of the equation equals 0, so that's good. My next step is to begin factoring. You always want to look for a greatest common factor. Both of these numbers are even, so I know at least 2 goes into both of them, but I think that there's a larger number. I think 6 should work. Yes. So let me go ahead and factor out a 6. So let's see. 6 goes into 54 9 times. And 6 goes into 96 16 times. Next, we want to factor completely. Well, it looks like maybe I have a difference of squares here. Let's check. So I'm just checking to see if I have a difference of squares. It looks like in the first term 3x is being squared, and the second term 4 is being squared. So I definitely have a difference of squares since both of these are perfect squares and we have a difference. So I can use the difference of squares formula. So I'm going to bring down my greatest common factor of 6, and then using the formula for a difference of squares, I'll have 3x plus 4 times 3x minus 4. Because remember that when you have a difference of squares, that formula is a plus b times a minus b. You could have also have used the area model here to factor this. You would have needed to multiply 9 by 16 and found factors of that product that equals 0. So now I've factored, and I have 3 factors being multiplied together that equal 0. So I can use the principle of zero products, and I can set each one of those factors equal to 0. With this first factor, 6 equals 0. There's no variable here, so there's nothing to solve. 6 does not equal 0. This is a false statement, so that goes away. For the second equation, to undo addition, I'll do subtraction and get 3x equals negative 4. To undo multiplication, I'll do division, and I'll get x equals negative 4/3. That's my first x-intercept. For the second equation, to undo subtraction, I'll do addition, and I'll have 3x equals 4. To undo multiplication, I'll do division, and I'll get x equals positive 4/3. That's my second x-intercept. Go ahead and pause the video and try example 5. Your first step on example 5 would be to get the right side of the equation to equal 0. So I would subtract 60 on both sides. So I'll have 42n squared minus 54n minus 60 equals 0. My next step would be to look for a greatest common factor, and I believe it is 6. Let's see. I'll have 7n squared minus 9n minus 10. Now I want to factor completely, meaning I want to factor what's left inside of here. To do that, I'm going to use the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. So we're looking for factors of negative 70 that add to negative 9. So let's see. I have 1 times 70, 2 times 35, 5 and 14, 7 and 10, and I think that's it. So it looks like the factors that are going to work are negative 5, or negative 14 and positive 5. Because negative 14 times positive 5 gives me negative 70, and negative 14 plus 5 gives me negative 9. So those are going to be the numbers that go in the empty spaces of my area model. The greatest common factor of my top row is 7n. The greatest common factor of the bottom row is 5. The greatest common factor of the left column is n. And the greatest common factor of the right column is negative 2. 7n times n is 7n squared. 7n times negative 2 is negative 14n. 5 times n is 5n. And 5 times negative 2 is negative 10. So right now, my factors are 6 from my GCF times 7n plus 5 times n minus 2. And those equal 0. From here, I can use the principle of zero products to set each one of those factors equal to 0. And now I can solve. 6 does not equal 0. That is a false statement. To undo addition, I'll do subtraction and get 7n equals negative 5. To undo multiplication, I'll do division and get n equals negative 5/7. On this equation over here, to undo subtraction, I'll do addition, and my answer will be n equals 2. So all of this was review from Algebra 1. You learned how to solve by factoring in Algebra 1. And you also learned how to solve by taking square roots in Algebra 1. In this method, we'll also have something new with this. The method is still the same from Algebra 1, but now that we've learned about imaginary and complex numbers, our answers could also be real numbers, or they could be complex numbers. So let's take a look at these ones. You'll use the solving by factoring method when something's factorable. But then you have problems like this that don't have a b term. So when I say that, I'm talking about like when we're in standard form, ax squared plus bx plus c equals 0. If you look at all these problems, all of them are missing that middle term. When that happens, there's a faster way to solve these, and it's by taking square roots. So what we always want to do is you want to isolate the variable. So you want to get the x squared, or whatever variable is being squared, alone. So on example 6, I have x squared minus 16 equals 0. We want to get x squared alone. To undo subtraction, I'm going to do addition. And I'll have x squared equals 16. In Algebra 1, you learned that you can undo a square by taking a square root. So I'm going to take the square root of both sides. The square root undoes the square, and that leaves me with x. And then the square root of 16 is plus or minus 4. You need to make sure that you have the plus or minus. This means that we have two answers. Our answers are x equals positive 4 and x equals negative 4. We can write that shorthand like this. So this plus or minus represents two answers, the positive answer and the negative answer. The reason why it's plus or minus is because 4 squared is 16 and negative 4 squared is 16, right? Because 4 squared is 4 times 4, and negative 4 squared is negative 4 times negative 4. Both of these equals positive 16. That's why we can have both a positive and a negative. So this is your answer. Let's try that again with example 7. We want to get x squared alone. Well, x squared, we're subtracting 60 from that. So to undo subtraction, I'm going to do addition. And I'll have x squared equals 64. To undo a square, I can take a square root. The square root undoes the square, and that leaves me with x. Whenever you take the square root of a number, it's always plus or minus. The square root of 64 is 8. So our answer is x equals plus or minus 8. Again, remember that this does represent two numbers, positive 8 and negative 8. On example 8, I want to get n squared alone. Right now I'm adding 4 to n squared. To undo addition, I'll do subtraction. And I'll have n squared equals negative 4. To undo a square, I'll take the square root. The square root of n squared is n. Whenever you take the square root of a number, it's always plus or minus. Well, the square root of negative 4, I can break that up into the square root of negative 1 times the square root of 4. The square root of 4 is 2. The square root of negative 1 is I. So here my answer would be plus or minus 2i. We have an imaginary number because we have a negative sign underneath the square root symbol. You need to remember from earlier in this unit that the square root of negative 1 is I. We will be using this a lot. Remember that that plus or minus represents two answers, positive 2i and negative 2i. On example 9, to undo subtraction, I'm going to do addition, and I'm going to add 3 to both sides. So I'll have k squared equals negative 13. To undo a square, I'll take the square root. The square root undoes the square, and that just leaves me with k. Whenever you take the square root of a number, it's always plus or minus. The square root of negative 13, I can break that up into the square root of 13 times the square root of negative 1. The square root of negative 1 is I. And if I try to simplify the square root of 13 using the birthday cake method, I see that 13 is a prime number. And so I don't have any pairs that can leave the square root symbol. So I can't simplify this any further. And so this would be my answer. Plus or minus I square root of 13. Again, I have two answers here. Positive I square root of 13 and negative I square root of 13.